So if you guys can go ahead and take a look at this problem. Basically what we have is we have a cosecant of theta equals -2, where theta is less than theta, or sorry, pi is less than theta, which is less than 3 pi over 2. And we're asked to evaluate for the cosine of 2 theta. Now, previously we did these problems. We were like looking at angles, right? Now we don't have an angle. We don't have some angles to plug into the formula. Like we know what the formula is, right? Now we have multiple formulas here. We could use, let's just use the first one here, cosine squared of theta minus sine squared of theta. But if we're going to evaluate this, guys, we need to know what theta is, right? And we don't know what theta is. We just know that the cosecant of theta is equal to -2. And if you guys remember, we actually spent a whole day on this last chapter, right? And it's going back just to basic triangles, guys. We know cosecant is a relationship, right, between sides of a triangle. It is the hypotenuse over the opposite side. And then if theta has to be between pi and 3 pi over 2, which quadrant does it need to be in? Third quadrant. So the triangle looks like this. Agree? OK. So now, again, remember, hypotenuse cannot be negative, so that needs to be a positive. That means that's a negative. So now we can use the Pythagorean theorem to figure this out. And you could say that's going to be 3. Now, again, be very careful with this, because this is where a lot of students made their mistakes, I remember, on their quiz. That's not a positive 3, right? Because you're going towards the left. It's in the third quadrant. So that 3 has to be a negative. Now that we have the triangle drawn, can we figure out what the cosine and the sine is of theta? Yes. Right. So basically all we did was we used the information to create a triangle that we can now evaluate for sine and cosine. So the cosine in this case is going to be negative square root of 3 over 2 squared. And then the sine is going to be -1/2. And also, FYI, if you guys didn't already notice, we could have actually just realized that this was the same thing as the reciprocal function, right? And therefore, you could have gone from there too. But anyways, in this case, so therefore, we square this. So therefore, that's going to be 3 over 4 minus, that's going to be a positive 1/4, which equals 2 over 4, which simplifies to 1/2. Yes?
So is there any specific situations where you cannot use the triangles to evaluate?
Where you cannot? What do you mean?
Like where you're not able to do the diagram of a triangle and figure it out? Because I will.
You can always use triangles.
OK, good.
But I mean, like, why would you want to, like, if I tell you what, like, if I say theta is like 45 degrees, like, you don't want to create a triangle once you already know what the angle is. So let's do another one. Let's do the one that's not on the unit circle. Let's do -3. Same process. Actually, you know what? I'll do secant here. Sorry, we're going to use, this is secant. Let's do tangent. OK, but no, to your question, guys, the trigonometric functions are all based off of what? Triangles. Every single problem, you can always create a triangle, right? But why is it then that when I say what's the cosine of pi over 6, we don't draw a triangle. We just go immediately to this? Because it's just easier, right? We're taking shortcuts. But yeah, what is it? Well, that is technically 30 degrees. It's technically a 30, 60, 90 triangle, which you could draw and do the opposite over the adjacent on, right? So we just use a lot of things as shortcuts for time savers. However, some problems we can't use on the unit circle. And that's